For this example, we are just going to graph it. I'm going to kind of delay it on finding like a majority of the information. We're going to just graph on this one, but then the next one, we'll find all the information, all the goods. Okay? So to start with, we have to determine if it's horizontal or vertical. Remember, we look at the very first fraction. Since it's y's first, we know that this is vertical. Our center is at 2, 3. Be very careful. It's not 3, 2, because it's still h and k. So just because the y's come first, that 3 is still the value of k, and that 2 is still the value of h. So don't get that mixed up. So our center is at 2, 3. Let's figure out our box. Okay, our box is associated with the values of a and b. A is equal to, or a squared is equal to 25, so a is 5. B squared is equal to 16, so b is 4. Since it's vertical, that means our transverse axis is going to be vertical as well. So from our center, we'll go up 5, and we'll go down 5. And then we'll go 4 to the left and 4 to the right. I do need to draw in our asymptotes here. Remember, they come at the corners of that box. That's why we draw in the box. And since it is vertical, that means my vertices should be here and here. Just to kind of harp on it, our vertices, we're going to add 5 to the y coordinates, so that's going to be 2, 8. And then subtract 5, so it's going to be 2, negative 2, and that's exactly where our 2 points are located. We cannot forget our foci. They are on the inside of our hyperbolas. And if I wanted to figure out exactly where that was, I would use the formula of c squared equals a squared minus b squared. But we just needed to graph this. Now this last one, yes, you're going to have to complete the square because it's not in standard form. All right? Now one thing, just like how I took the time to show you the difference between a circle and an ellipse. Remember, a circle, the x squared term and the y squared term are the same. In an ellipse, the x squared and the y squared, their coefficients are different, but they're still the same sign. Here, you know you're dealing with a hyperbola because your x squared term and your y squared, not only are they different, but they're also different signs. One's a negative while one's a positive. That's how you'll be able to tell that you're dealing with a hyperbola. And then on top of that, since you know you're dealing with hyperbole, that means that it has to equal 1. So when we complete the square, we're going to make sure that once we kind of, get everything done and simplify, our last thing is going to be to divide by what's on the other side of the equal sign. So I'm going to put my x's together just like before. I'm going to put my y's together just like before. And in order to complete the square, your x squared term and your y squared term have to equal 1. So from the first 2 terms, I'm going to factor out a 25. So that's going to leave me with x squared plus 4x. And for my y's, we are going to factor out not just the positive 16, but a negative 16. The reason why is because, remember, hyperboles, it's the first fraction minus the second fraction. So we have to take that negative out as well. Plus, on top of that, if we didn't, our y squared wouldn't be 1. It would be a negative 1. When I take out a negative 16, this is going to turn into a negative number. And it's negative 6. And then whatever I do to the left side, I'm going to do to the right side. So completing the square. Remember, we take half of b, which is going to be 2, and then we square it. 2 squared is going to be 4. We do it again. Half of b and then we square it, we get 9. Now we're not going to add 4 and 9 to the other side. Don't forget, when you factor out a number in front, you actually have to multiply that number to whatever you got when you completed the square. So instead of adding 4 to both sides, I'm going to add 100. And instead of adding 9, I'm actually going to add a negative 144. Yes, you do have to multiply the negative 16, that number on the outside, that negative number, by the number on the inside that you got when you completed the square. So then from here, we'll simplify all this. This will be 25, x plus 2 squared, minus 16, y minus 3 squared, equals, let's see, 444 plus 100 minus 144 is 400. And since this is a hyperbola, it has to equal 1. So I'm going to divide every single term by 400 to get our standard form. That's going to be x plus 2 squared all over 16 minus y minus 3 squared over 25 equals 1. And that is the standard form for this hyperbola, which we are going to find all the information for, and we are going to graph it. Since our x is our first, we know that it's going to be horizontal. The value of a is going to be 4, and the value of b is going to be 5. Let's figure out the value of c so we can get our foci going. That's going to be 16 plus 25, which equals 41. Take the square root. C is going to equal the square root of 41. The length of our transverse axis is going to be 8. The length of our conjugate is going to be 10. And now let's find all the goods. We have a center at -2, +3. We have vertices. Since it's horizontal, we're going to add the value of a to our x-coordinate. So that's going to be 2, 3. And we're going to subtract it as well, so that's going to be -6, 3. Our foci, we're going to add or subtract c from the x-coordinate, so that's going to be a -2 plus or minus the square root of 41, 3. And our asymptotes, it's going to be y equals k, which is 3, plus or minus, since it's horizontal, it's going to be b over a, so 5 over 4, x minus h, so x plus 2. So we did complete the square. We found the values of a, b, and c. We found our center, our vertices, and our foci, as well as the equation for our asymptote. Now we're going to graph this. Our center is at -2, +3. I'm going to get my box going. Horizontal, so that means the value of a is going to be 4 to the left, 4 to the right. My scale goes by 2, so that's going to be 2, 4, 2, 4, and up 5, down 5. Here's my box. Remember, the asymptotes are drawn going from the corners of that box. And just to recap, if I went from the center, okay, if I went from the center up 5 over 4, 5 over 4, there's the slope right there. And lastly, the branches. I have a vertex at 2, 3. And then -6, 3. The foci is always located on the inside and on that transverse axis if I were to extend it. That is how you graph hyperbolas. Now we're going to shift gears from graphing to writing the equations for hyperbolas when they have certain characteristics. Okay, very similar to ellipses, you do need to kind of like work your way backwards, finding the value of A, the value of B, and then also finding your center in order to write the equation for your hyperbola. But the one thing is you do need to identify whether it's going to be horizontal or vertical, because that's going to tell you whether or not your y's are going to be first or your x's are going to be first. So let's start with this one. Vertices are located at -3, -6, and -3, 2. Your foci are located at -3, -7, and -3, 3. Now the fact that none of your x values change, the fact that none of your x values change is only your y values, that right there is an indication that this is going to be an hyperbola that is vertical. Okay? So if you want to make a note of that somewhere, if the y's change, then it's going to be vertical. So if the x's are the ones that change, then it's going to be horizontal. So because we know it's vertical, that means our y's are going to be first when we do our equation. And just remember, it's a minus on the inside, not a plus when you have your hyperbolas. Let's go ahead and let's find our center. Since we have our vertices, our center is just the midpoint between our vertices or the midpoint in between our foci. So then we basically just have to figure out what is the center. Well, since the x's are the same, then the center is going to be the x-coordinate is still going to be -3. But to find our y's, we basically are going to find the midpoint between the two y values. So -6 plus 2 is a -4. When we divide that by 2, it's going to be a -2. So our center is going to be -3, -2. So that means that h is going to be a -3, which is going to turn that whole thing into a positive. And then that means our k is going to be a -2, which means we're going to turn this into a positive as well. Now our vertices are always located it's always located on our transverse axis, which is always equal to 2a. So we basically just need to figure out what is the length between our vertices. The length between our vertices is 8 units. So that means that 2a is going to equal to 8, which means that a will equal to 4, which means that a squared is going to be 16. So then we know that the denominator right here is going to be 16. Now our foci does not equal, the distance between our foci is not going to be equal to 2b, but it's going to be equal to 2c, okay? Because from the center to your foci, that is basically c units. So from foci to foci, that's 2c. The distance between our foci is 10 units, so then we're going to divide that by 2, and then we're going to square it to get c. Now we do need to figure out c in order to figure out b. We're going to use that relationship of c squared equals a squared plus b squared. C squared is 25. A squared is 16. So when we subtract, we see that b squared is going to be equal to 9. And once we figure that out, we will have our equation for our hyperbola. So just like before, we work backwards. We use our vertices or our foci to find our center. It doesn't matter which one, we'll still get the same center whether we use our vertices or our foci. We still have to, the distance between your vertices is still 2a. Distance between your foci is still 2c. We just need to figure out if it's vertical or horizontal, so that way we know if the y's go first or the x's go first. The next one, our vertices are located at a -3, 0, and -9, 0. And we know our asymptotes. So, since our vertices, we know that's going to be equal to 2a. The distance between our vertices is 6. So a is equal to 3, which means that a squared is equal to 9. And we also know its orientation. We know that it's going to be horizontal because our x's are the ones that change. with those coordinates. So since it is horizontal, we know it's going to be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. I'm going to go ahead and trade out the a squared for 9 since I already know that that's 9. And I'm going to go ahead and find my center since I do know my vertices. Okay? Since my x's change, I'm going to basically find the halfway point in between them. The y doesn't change, so that's just going to be 0. That's a negative 12 divided by 2, which is a negative 6. So h is going to be a negative 6, making this a positive. And since k is 0, that's basically just going to turn into a y squared. Now we just need to figure out our b, or our b squared. Since we're given our asymptotes, and this is horizontal, we know that for horizontal, the equation for our asymptote is going to be k plus or minus b over a, x minus h. This b over a represents our slope. Our slope is going to be 2, or negative 2, really doesn't matter. So what I'm going to do is I'm going to set up an equation that sets my slope equal to b over a. So 2 equals b over a. No matter whatever b is, whatever a is, when you divide it, should give me a positive 2 or should give me a negative 2. So, since I already know that a is 3, I'm going to plug 3 in and then just do a little bit of multiplication to solve for b. b is equal to 6, which means that b squared is going to be 36. Now, b could be a negative 6 or it could be a positive 6. It really doesn't matter. We just know that one's going to be a positive, one's going to be a negative. But for the sake of our equation, for our hyperbola, it's squared anyway, so it's always going to be positive. And there's the equation for this particular hyperbole. This next example, again, we have the vertices, which means we can figure out. Hopefully you guys were like, oh, well, then we know that 2a is equal to whatever. Good. And we have our conjugate axis length, which means that the conjugate axis is equal to, hopefully you thought 2b, I mean, 2b, so yes, good. I haven't had any pause this videos and try to get the information that we need to write the equation, so I'm going to have you guys pause this video, try to get the information for the so you can write the equation and press play when you're ready to see it worked out. So the vertices were equal to 2a. The distance between those 2 points is a total of 4 units. So a was equal to 2, which means that a squared is equal to 4. The conjugate axis was equal to 2b, so 2b had to equal 10, which means that b was 5, which meant that b squared was 25. So far, we pretty much have almost all of our information. We just need the center now. Since the x's don't change, but the y's do change, we know automatically that it's going to be vertical. And our center is going to be 3, 2 plus 6. So it's going to be 3, 4. And since it's vertical, our y's are going to come first. So that's going to be y minus 4 squared, x minus 3 squared. The a's go underneath the first one, the b's go underneath the second one, and there's our equation. Hopefully you're able to find all that information out. This one you really didn't have to find a C or anything like that. So for the last one more. It's kind of hard to see. So of course I copied and pasted this from someone else. But we have the foci is at 2, negative 2, and 12, negative 2. And we have asymptotes y equals 3/4 x minus 29 over 4. And y equals negative 3/4 x minus 13 over 4. Since our x's change, we know that it's going to be horizontal. So again, anytime your x's The x-coordinates change. We know that it's going to be horizontal, which means that our x's are going to be first in our general equation. And since we have the foci, we can go ahead and find our center. We're going to find the halfway point in between the x's, since they do change, the y stays the same. So it's going to be 14 over 2, which is going to be 7, negative 2. So then that means h is going to be 7, k is going to be negative 2. So then that's going to give us an x minus 7 and that y plus 2 over here. Now to find a and b, we use the fact that we're given the asymptotes. Now, because it is horizontal, we know that in the formula, the equation for your slope, if it's horizontal, is b over a. So that means our slope needs to equal 3/4. Whatever the value of b is, whatever the value of a is, it should equal 3 over 4. Yes, it is just that simple. A is 4, b is 3. So a squared is going to be 16, b squared is going to be 9, and that is what we plug in. A squared is 16, b squared is 9, and we have our equation. The trick is for these, you just want to make sure that you know it's b over a versus a over b because it's horizontal. And those are a few examples of how you write equations of hyperbolas given different characteristics. Now we're going to do one last example that deals with eccentricity. And I'm actually going to take off these bottom two because they just kind of go over the same information when it comes to determining eccentricity. It is the formula c over a. And remember, since it's a hyperbola, the number should be greater than 1. And it basically tells you how uncircular it is. So the bigger the number, the more circular it is. The smaller the numbers, in other words, the closer it is to 1, the more stretched out it is. So our y's are first, but it really doesn't matter. We just know that a squared is 48 and b squared is 36. Okay? To find our c, we do use that formula of a squared plus b squared. So that's going to be 48 plus 36, which is going to be, when I add those together, 84. So then I'm going to take the square root of both of those, and c is going to equal the square root of 48, which does simplify down. Now the square root of 84 does simplify down. It breaks up into square root of 4 times the square root of 21. So that's 2 root 21. That's our numerator. And a is going to be the square root of 48, which simplifies down to be 16 times 3, which will be 4 root 3. Now when we reduce this, of course, we can always type it into our calculator in the decimal. 2 goes into 2 and 4, so that reduces down to 1/2. And the square root of 21 divided by the square root of 3 is the square root of 7. This will be the non-calculator way. This will be the exact answer. But once we type that into our calculator, we'll get 1.32 out of the eccentricity. So again, the closer it is to 1, the less circular it is. So this one's looking more stretched out. So if we were to graph this, it would look something like this. If we wanted to go into detail with it. But that's pretty much the bulk of hyperbolas. Very similar to ellipses, with a few differences here and there.